Want to know how to secure your code and survive a total loss of disk drive or machine completely and not miss a beat using Git? I've also got some exciting news to share you as well about the next video series and also something else epic, so stick around. So I'm your host. Learn with me as we build some robots, bring them to life with code, and have a whole lot of fun along the way. So let's, without further ado, get over to some slides. Okay, so today's all about Git and source code control, and we're going to be looking at how to get up and started with Git right from the get-go. So what is this all about? Why are you interested at all in source code control? Why do you need it? So as you're working on your code, you need to make sure you protect that investment of time and effort that you've made putting into that code. You know, you might have perfected some lines of code, got it just right, you might have been working for days on this thing. You don't want to then subsequently mess that up by making some changes that you then can't remember how to get back from there. And it's not just sufficient to keep lots of separate versions of these code just by changing the file name and renaming it. That can get old pretty quickly and you don't know which version has got what in it. So we use something called source code control for managing our source code, and this is the best way to manage it. And there's been quite a few in the past that we can look at, but Git is the most favorited by the industry. It's the easiest to use and the most robust, I would say, as well. So if you want to share your code as well with other people so that they can merge it with what they're doing, they can make changes to their version of your code. They call this forking, and we'll get to why that is in a minute. And you know, if you want to make sure that your code is used widely, if you've been making something epic from a robotics point of view and you want to make sure other people are using it, then you know this is one of the best ways to do it, is to use source code control. So there's a couple of different types of source code control. You could basically not do any and just hope for the best, which isn't a great idea. You could, as I said before, start saving file names with like version 1, version 2 at the end of it, or so on. You'd end up with a lot of files in that, and there'd be a lot of file management to be done as well. And it'd be difficult to link a specific build of code to specific versions of files without that getting really messy quite quickly. And then backing up, how often do you back up? Where do you back up to? How do you know that's safe and secure? How can you give somebody access to your code if you're only backing it up? So we want to use source code control, and there's quite a few of them around. Like I said, there's CVS, which is one of the very, very first ones that was out there. It's very difficult to use, especially if you want to branch it and then merge the code back in. There's Subversion, or SVN as it's also known. That was quite a favourite of mine before I discovered Git. And then there is Git, which is just the best. It doesn't stand for anything as far as I know, it's just a silly word that Linus Torvalds, the inventor of Linux, made up. So he also wrote Git. So code is mostly text. You might have JPEGs or other resources that make part of your folder where you keep all your files, for your source code. But mostly source code is text. So Git understands text. It understands when you've created new lines of code, when you've deleted lines of code. It can figure all that out because it is just text. It uses something called hashing to figure this out. And it can help you keep track of your versions of code. So let's get to the sort of basics of this. So if you have a folder, your code within that folder is called the tree. So you've got lots of files within there, and I've got a bit of an image on screen there that you can see. Lots of files in different subfolders. That whole structure is called the tree. And you might have heard terms like root folder when you're talking about your hard drive directory. So the root and tree and branches, these are all kind of terms that we'll be using to do source code. So the folder structure that stores your files in the tree is the main root, and the folders that come off that, they're not called branches, they're just called folders. Branches are, as we'll come to in a minute, versions of your code. So the place where all these files are stored is called the repository or repo. So where all the files are, that's the repository. Branches, as I was mentioning, they're not the folders, they're actually a point in time snapshot of your code that's given a name. So in source code control, a branch is an entire copy of all the files and folders at a point in time. Branches can be used to experiment, develop, perfect code without affecting the main master branch of that code. And you can create as many branches as you like. They don't cost anything. They use very little hard drive space, because the way that Git works behind the scenes, it's only storing one copy of the file and just the changes to that file. So it's very efficient on disk space usage. And what happens when we branched our code? So I'm using some very high technology here. Is that reversed? No, that's right. So you can see there we've got our main line of code there. That's our master branch, and when we sort of come off to one side there, that's called a branch. And when we merge that branch back in, that's called a merge. Merge and branch, quite simple ideas. And you can see on the screen there, in this line of code here, this is the SMARS, is it SMARS lab or SMARS library? You can see there's been a main line there. It's been branched off. There's been some experimental stuff. It's been checked in, branched off, checked in, and so on. And then at the very end, it's all merged back into together to the master branch when everything's working cool. So merging may be successful, and both sets of changes sort of merge together and overlap, and where the files don't overlap. And I'll come to what that means in the demo in a minute. Merges might have conflicts. So if two files have been changed in two sets of the things, that, it won't know which one is the right one. So you'll have to step in there and decide which is the correct bit of that line of code, and it will help you understand what the changes are, and you can select which one is the correct one. And then once you've got that understood, it can then complete successfully the merge. And we'll do an example of that, because I probably mangled the explanation of that a little bit. And when we do a merge, that's called a pull request. So this is because if you have a repo and you give somebody else a copy of that, if they want to merge their code back into the master branch that you own, they'll have to request that you pull that into your repository, and that's why it's called a pull request. So that's the idea. It's Git is one of those really great ideas where many people could be working on many different branches and versions of your code, and it can all seamlessly come back together because of these hashes, because of Git understands where things were and which version is the correct version, and so on. So, some conventions. So we only commit working, stable, quality code to the master branch. Now this is really when you're working with large software engineering teams. For your own personal use, you can probably get away with whatever you like, but as a convention, it's best that you only check into the master branch stuff that you know works well. It might be that you later discover bugs in it, and that's fine, but as you commit, you should have a good understanding that this is a good, solid, tested piece of code. Another convention is that when you branch off, you only really work on one feature at a time, and a feature might be, a block of code. It might be one feature, one new idea, one improvement, enhancement, bug fix, but basically just one at a time per branch, and that makes it so much more easier. Particularly if you're trying to track down a bug, you can see in your log of all the things that you've checked into Git where that particular feature was, so it makes it a lot easier to debug. And naming conventions help you manage your code better. So if you name your branches consistently, again, it helps understand when you're looking to try and troubleshoot something where things have come from. So that's conventions. So the first thing we need to do is get Git. So if you have a Mac, you already have that installed by default. If you have Linux, you can use the sudo apt-get git install. If you have Windows, you'll need to go to the downloads section of the git-scm URL that's on the screen there and download the latest version of the installer. You can also do that if you're a Mac or Windows, Mac or Linux user as well. You can go to that website, but they have better ways of doing that. So, okay, so once we've got Git, we can start using it. So the first thing to do is to create a nice empty folder. That's where we'll start. So what I will do, as we do this, I will start to flick backwards and forwards to a practical example. So if I go to here, which is, just pull it up, VS Code, and I've got a folder here. It's just got the file readme in it, And I've got a terminal down here as well, so if I do ls, which is a command to list files, or ls.l for long, we can see there we've just got a readme file. There's nothing else in there at the moment. So let's pretend that we are going to create a new file that's called hello.py, and this is just going to print to the screen hello world. Oops, hello world. Okay, so if I now do ls-l, we can see we've got the readme file and we've got the hello.py. And this is in a folder that's just called Git at the moment. It doesn't need to be called Git, that's just what I called it when I created the folder. So what we want to do first then is, let me just go back to our Keynote. And let's just switch over to Keynote on there as well. So what we want to do in that empty folder is type Git init. And I've got somebody on stream here. Let's say, hi Simon, how you doing? Thank you for joining me. Glad you're watching. I didn't realise you'd watch more of these. So yes, we're just going through Git at the moment and now how to use that. So yes, we've got a nice empty folder. It's got 2 files in it. That's fine. What we need to do first is do Git init. So let's go over to our terminal, to our code, and let's do that. So we're going to do Git init. And what that will do is that will initialize some special files that are actually hidden, but it makes it so Git understands that this is now a repository and it's ready to put files, add files to that repository. So at the moment we're not tracking anything in this repository. Even though them files are within that folder, they are not currently being tracked by Git. So if we do git status, which is a command of Git, you can see there no commits at the moment. And there's 2 untracked files that are in red there. So the readme.md and the hello.py. So we want to add them to the Git repository. So if we do git add and then dot, we could either do the actual file names like git readme.md, or if we just want to sort of add everything that's in this folder and recursively down as well in every subfolder, we can just do git dot. So if we now do git status again, you can now see that it's, although we've not got any commits, we are now tracking these 2 files. So let's just head back to our Keynote for a second and see what we're doing next. So we've done git add. So the next thing we need to do is commit. We need to commit a message with these files. And what that will do is those files that we're tracking, it's going to add them to a special area of Git. It's essentially a hidden subfolder. But it's going to track them 2 files, it's going to commit them and say, right, they're now checked in, they're now protected, don't worry about any changes to that. So, hi Spineborn, how you doing? Thanks for joining the stream. So you're saying you have to look at the start to follow. It's okay, we've not actually gone through too much just yet. We're only just getting into this, so I'm more than happy to show you what we're up to and start again if you like. That's not a problem. So we've literally just started looking at the only bits you missed, the first 20 minutes, were just about why we have source code control and you know, what the different options are, if you like, there. Basically not doing anything or using something like Git to track our files. So all we've done is created a blank folder. We've created 2 empty files that are in there. There's just a hello.py, which has got print hello world in it. If I just share my code screen, you can see what we've got there. So we've got a hello world file there, and we've got a readme that just has hello in it and nothing else at this point. So what we've then done is we've gone into our terminal, and if I just wind back here for a second, the first thing we did is do git init, and that initializes the Git repository in that folder. It essentially creates a hidden .git folder. In fact, we can see that if we go over to the folder structure here. Let's see if we can find it. No, I think it actually hides it away. So there is a hidden, I could do an ls command in a minute and show you where it is, but essentially there's a .git folder. Within there's some special files that Git understands, and that's what it's using to track these files. So we did a git status to show that there's been no commits and that it understood that even though there's a repository created, there was no files within that repository yet. So that's what the readme.md and hello.py, it says, are untracked. We then did git add and then dot, which adds all the files within the folder and any subfolders to the Git repository. It doesn't check them in, it just adds them to the tracking. and then we did git status to see where we're up to, and that's where we are now. So we've not committed anything yet, we've just tracked them. And the reason you might think, well, why is it not actually added them to the commit yet? You know, why wait for that? And it's because we want to write some code, we want to test our code, and once we're happy that that's in a good state, that's when we do the commit at that point. So say we're happy with our code at this point, we can do git, and then we can do git commit -m for message, and then we have to type in what our commit message will be. So we're going to say first commit, and I might just sort of say added hello and readme, something like that. So you can see there it said there is 2 files that have changed, and it's inserted into the repository 2 files, and it's what the create mode is, that's to do with like file permissions and things. Don't worry about that. It's essentially just added them to the repository. That's all we need to do. So we now do git status. We can now see that we're on the master branch and there is nothing to commit. The working tree is clean. So we've not made any changes to them files yet. So it's basically saying you're good to go. This is a fresh repository. You've got a commit that's in there. If we do git log, we can see what's going on there. We've got one commit, which is the first commit, added hello and readme. That weird code there is the hash itself, and that's what it's using to track versions of files. So if I gave this copy of files, one to Sveinborn, one to Simon, you would both have that exact same number. If you started working on your individual versions of that code, you'd each get a different version of that number when you then commit and make changes. And if you then sent those folders back to me, my version of Git could figure out what's happened, who's changed what, and how to merge them back together if we did a pull request. So okay, so that's the first thing. We've committed. We've made our first commit. So let's go back to Keynote and see what else we're going to do next. So now we're going to check out a branch. So to list our branches, we just do git and then branch, and that will show you all the branches that we're currently working on. And you can see in the right hand side of the screen there, there's quite a few different branches on my SMARS library that I was working on. There's at least 5 different ones there, and the master one, which is green and has got a star next to it, is the current branch. So that's how you know it's got the little star next to it. So check out to check out a branch, and that means basically to switch whatever you're working on to that branch, and all the files that are in that branch will then become in your particular branch. They'll move over. It's kind of like a moving over or moving into that folder. They'll become the current branch. So you can work on files, you can commit them to a branch, you can switch over to an entirely different branch if you want, work on that one for a bit and then switch back to another one. You can keep doing that until you're ready to do the merge. So let's go back over to code and let's create some branches. Okay, so Sveinborn was saying you're really looking forward to this topic and thank you so much. Little accident before bedtime, which made me later than normal. Oh, bless you. Little accident, little boy. Well, yeah, I didn't think it was you. No judgments, no judgments. Okay, so I'll tell you a story as well shortly about when I was at school. I was a bit of a fussy eater, and I've got a little story to share with that. But let's get back to Git for a second first. So what we're going to do, we're going to go to our terminal again. I'm just going to type clear, which is just a command to clear the terminal screen. It doesn't do anything else. So let's have a look where we're up to. Git status. So we're working on our thing. We want to create a branch. So we do git branch. And at the moment, if I just type enter, it's going to list all the branches that there currently are. So there's just one, which is called master currently. So if we do git branch, and then let's call this one. So the convention I learned when I was working for a software company was you type the word try, because you're going to try something out, then underscore, and then your initials, and then underscore what it is you're going to do. So let's do something awesome. So now if I do git branch, I'm now on, I've not checked it out yet, but I've created a branch, and the branch is essentially a copy of exactly what's in master at the point in time that you do the branch. So if I now do checkout, and then try KMC and something, oops, I have to type in the right case, something awesome. it says I'm switching to the branch, try KMC something awesome. So if I do git status now, or git branch, you can see now the star is next to try KMC something awesome. So let's make some changes. So let's create users.text. We'll have in here Simon. We'll have Svein Bjorn. Don't think I can do the O character correctly there, but I'm sure you'll forgive me for that. And we'll have Kevin as well in there. Okay, so I'm going to save that. We've now got a users.text. Let's add that file. So if I do git status, we can see the users.txt file isn't being tracked currently. So if we do git add and then dot and then do git status, you can now see that that file is now being tracked. So we can now do a commit. So let's do a commit and we'll say added users.txt. You can see on the message there that it's added users.txt, and if we do git status, it says we're all clean, we're golden, everything's good. So if we now wanted to switch back to the master, if we do git checkout and then master, look what happened to our users.txt. That vanished, disappeared. And we haven't lost it, that's actually in the other branch. So if we go back to checking out, let's do checkout something awesome, look what appears. The users.txt has appeared again. There it is. So this is what you've got to get your head around. When you commit things to a branch, you're essentially putting them into a special area, and you can switch which branch you're on, and when you switch, it will move all the files back into the other area and then bring back to the current folder whatever is in that branch. So there we go. So what we want to do next is to do a pull request. So we want to bring that users.txt back into the master branch. So what I will do, I'm just going to make my other screen open there. So let me just bring that up on the other screen just to make sure I get it right. Okay, so I'll tell you the secret. When I use Git, I will add things and switch branches using Visual Studio Code. I rarely use the command line itself. I might do a bit of adding or a bit of creating, but that's pretty much it. Everything else I use different tools for. So what I will do with code, if I click on this little icon here, which looks like a USB thing, that's the source code control thing, and I can do things like pull requests here. So if I do a pull request, I need to go over to the master branch and then pull in the try branch. So let's do that. If I go to let's see, branch, and let us actually, if we click down here, we can see which branches we've got. So I can click back on the master branch, and that hasn't got the users.txt. You can see it says deleted there. So if I now do the pull request, if I go back over to here and let's see, pull from, we should be able to pull from, oh, that's to do with when you have remote repositories. Let's just merge the branch from the try one. So what it's going to do, it's going to look at those and it's going to say whether it can do it or not. So let's see what's happened. So it's quite happy that it's pulled in the users.txt from the branch that we've just merged in. And we can see there that users.txt is now present on the master branch. So if we look at that changes there, let's do a quick refresh. Yeah, it's quite happy with that. It's pulled in from the try branch into the master branch successfully. You can do that using the command line, but I haven't written my notes for that, so you'll just have to forgive me for that. Right, so let's get back to Keynote for a second, and let's continue our journey on with this. So, cloning an existing repository. So more than likely what will happen is you're not often starting from scratch with the code, you might be bringing it in from a third party. So what we might do is something like, so you can see on screen there I've got SMARS lab, that's some source code I created to help with our SMARS robots, with our little 3D printed SMARS robots. And it helps us control it. That's what SMARS Lab does. So let's try and bring that in. So if I go over to code once again, and let's go to the terminal. And this time I'm going to come out of the Git folder, and I'm going to type in Git and then clone, and then I need to type in carefully that URL which we had on screen a moment ago, which I just happen to remember, because it's github.com/Kevin McAleer/SMARS Lab. And what will happen is Git will reach out to the internet, it will grab the files from that location, and it will bring them all across and unpack them, because it's essentially a zip file. So it'll unpack them, creating the Git repository and making an exact duplicate or clone of it. So if we now do git status, we can see there, oops, so we need to go into it, sorry, we need to cd into SMARS Lab. Let's just clear the screen, git status. We can see now that we're on the master branch. We can have a look around and see what other branches we've got. We've just got the master branch. We can do git log to see all the different check-ins that have ever been made into that. You can see there it says tidied up all files, updated version, blah blah blah. And we can start using it. So if I go to this folder here, and let's open up the folder that we're working in. So let's just back up one, go into SMARS Lab, open that up. Yep, so you can see that now, yep. So you can see all the different files there that are in the SMARS Lab folder. So if we click on one of the, I don't know, the to-do.md, we can see all the stuff that we've been working on there. So if I then start to make changes to that, I'm only making changes to my local copy of that repository. Any changes I might make, I can actually push back up to GitHub. And that's where the magic happens. That's where my protection happens. So I mentioned at the start of the stream that you want to secure your source code. Excuse me, the source code that you've been creating and spending all this time and effort on. You want to make sure that that's really safe. So the iMac that's in front of me, I've got this 27-inch iMac, and something weird happened with it, and it crashed, and I lost everything that was on it. But I didn't lose any of the code, not a single line of code, because every time I wrote some code and I committed it and then I pushed it up to the cloud, up to GitHub, it meant that I have a safe copy of it. So I can go onto any other machine, I can pull the files down, and we'll show you how to do that in a second. And that means that we've always got the latest version, and we've secured the latest version as well. So let's go back over to our keynote and continue our journey on there. So we've just done a clone. So we've looked at committing code where we do git commit and then the message. Now we can also do this with Visual Studio Code. So let's go back to Visual Studio Code. And instead of doing the git commit, if I make a change to one of these files, so that to-do list there, let's go to the bottom and say tidy up some files. If I save that, you can see there as well, it says you a few seconds ago made this line, and it's an uncommitted change. If I look at the line above, it knows that I did that change a couple of seconds ago as well. It can see that particular line of code there is 8 months old. And you can see the whole history of that line of code, because Git understands this and it's integrated with VS Code. Very powerful stuff. But you can see that little green thing there. That means that Visual Studio Code understands that this is a change and it's an untracked, it's an uncommitted, I should say, line of code. So let's go over to the source code thing here, and we can see that the to-do file is now changed because we've added that line to it. So let's get rid of, we don't care about this cpp properties.json. That's just something we can ignore, so we just discard the changes for that one. Yeah, that's fine. However, the to-do one, we can type our commit message in here. So I might say added to-do line, something like that. If I add that there with the plus button, that change is now stashed. It's now in the things that I want to commit. And if I click the little tick button there, it will then make that commit locally. And down on the bottom of the screen here, I'm just making sure that you can actually see this on your screen. Yep. At the bottom of the screen here, there's a little up and down arrow. And what that means there is, it knows that there is a change locally that I need to push up to GitHub. So if I click on that, it spins this little wheel round. It's basically synchronizing it up to GitHub, and therefore it's now protected. All them changes are now on GitHub. And if we want to go over to GitHub, which I've just got on screen, let me just share that on here. So if I go to here, yep, there we go. So if I go to SMARS Lab, which we've just downloaded, and you can see there, it says 1 minute ago there was a commit, and the commit message was added to do line. So if I click on that, I can actually see there, this is what they call the diff file, the difference between the two commits, and it sees there that I've added line 41 in green, and I've tidied up some files there. So we can see there that it's actually added this file, and it understands, because it understands text, what's changed. That is awesome. That is really clever how it does this. Okay, so that means we can also make changes on GitHub itself. So if we go back to GitHub here, we could go to that to-do file. We can click on that little pencil icon. We can go back to the very bottom of this, and let's add another one. So added another line like that. If I commit that change, that's now committed. If I go back over to Visual Studio Code, let's get rid of that. And if I just press this little synchronization thing, it'll know that there's some changes. And there it is. Added another line. Added a few seconds ago. So this is really powerful. This means that our source code can be completely tracked, saved up to GitHub. You do need to create a GitHub account. Very trivial to do that. Just go to github.com, create yourself a free account, knock yourself out. It's very easy to get started with that. Okay, let's get over to Keynote. I will read your comments just in a second. I just want to get to the end of this bit. So pulling and fetching code. So let's just cover this off. So when I made that change to GitHub and I clicked that little wheel, what I was doing there is called a pull. So I was pulling all them changes from GitHub down to my local repository. But let's say I want to do that without bringing those changes in. I want to bring them down locally, but I don't want to apply them to the library that I'm currently working in. That's called a fetch. So it fetches the changes, it sort of stashes them ready to be applied. It doesn't actually apply them, whereas a pull actually applies it to the the branch that you're currently in. So that's the difference between pull and fetch, and that little wheel essentially does a pull. And VS Code can actually do a fetch every couple of seconds. It will pop up while you start using it. When you start using GitHub, it will start saying, would you like me to do fetch periodically in the background? And I think every couple of seconds it just does a fetch to see, have you got the latest version downloaded? And to push the code back up, we do git push. So we can also do that. We open up our terminal window. Let's go back to here. If I do git push, it will push whatever changes I've got back up to the cloud, to GitHub. So if I do another line, save that, add the change, added another line. Good grief. So I then do that commit. So instead of pressing that little wheel, you can see that it's got the up arrow there and they're ready to go. If I do git push, it will essentially do that task for me. So you can see that it's right in the objects, it's pushing things up, and now that little up thing has disappeared because we're now on the latest version. If I do git status, we can see there we're on the latest version, nothing to commit, working tree is clean. Okay, so let's see what else we've got. I think that's it for these slides. So let me make sure I've covered off everything. So we've created some code, we've downloaded Git, we've created a repo, we've added some code to the repo, we've then committed that code, we've made some changes to that code and recommitted it, we've looked at the log file, which if I just do git log, you enter into this sort of interactive log there. You can use the up and down arrow keys to see all the different commit messages that are in there, as well as the hash that's in there too. Don't need to worry about the hashes for now, that's just its way of tracking things. And we branch some code, so if we do git branch On this one, I think we're just on the master one, but on the other one that we were using before, so if I go back to the code folder, let's just do that. There we go, the Git folder, sorry. And we open up that terminal then again, Git branch. We can see that we've got two branches there. We've got the master branch and we've got the try KMC something awesome branch as well. So what else can we do? So let's try doing two commits that clash so that we can see what happens when we do that. So if I go back to that SMARS lab one, we're going to change the same file in two different places, and then we're going to try and do a pull request and see what happens. So this local version, I'm going to type the word on line 44, this line should break Git. I'm going to save that locally. I'm then going to go over to GitHub. I'm going to edit that file, and on line 44 I'm going to type my happy place, and we're going to commit that as well. So I've committed that. I'm going to go now over to here and synchronize the changes and see what happens. Oh, so we need to add that as well. So let's try that, see what happens. It might actually accept that because I've made it, you can see there's one up and one down. Let's see what happens when we try and merge it. There we go. So the merge of the master branch has detected that there is a conflict. You can see there is a merge conflict to resolve the conflicts before committing. And you can see there it's got this less than arrow, and it's also got the greater than arrow down there. So the head is our local master version. We typed in the line should break Git, and now that equals means that's where the changes end, that's where the differences end. And then on the remote version, the incoming change, you can see there in blue, my happy place. So we as the developer have to choose which the correct line is. There's no way a machine can figure this out. We have to decide what we think is correct. So if I go in here and let's see, you can either accept both, you can compare them, or you can accept the incoming change. So I'm going to say accept the incoming change, my happy place. So if I now do that, and let's just see, so I've saved that. Just merged happy place. Let's do that. Let's try the. It's not possible because you've got unmerged files. So do I need to do something more on that? I thought that was sufficient. So merged files. Do we add that one? There we go. Is that it? Yes. Sorry, I just haven't done it right. So I can now push that up. Let's see what happens. Synchronizing the changes. Everything's done. Great. So if I now go over to GitHub and I just refresh that screen, we should see that new version be pulled through. Okay. My happy place is at the bottom there. Great stuff. And we can see that it was done 2 minutes ago. Great. So that's breaking it and then fixing it again. What else have we done? We've looked at switching branches. We've looked at getting back to a good place. So yeah, so if we make some changes on our branch and we don't like that, we can actually just delete that branch, check out the master branch, and then just branch again from there if we want. That's a really easy way to sort of get back and undo any changes that you've made that you're not happy with. We've done a pull request, we've done a merge, and we've also checked out our master branch. So let's have a quick look over in the comments and see what people have been saying there. So Svineborn says that is so cool. Isn't it just so cool? I love this stuff. This has saved me so much time, just having everything safe in GitHub using Git. Svineborn also says when you're working in a team and you have all versions, so if somebody does something bad, not everything is lost. That's correct. And what happens, you see, is when you make a change to a file, Git will run that through a hash function. And a hash function is a special mathematical algorithm that no matter what you put in there, it will generate a number. It's always the same length of number. It's like a 64-bit number. And it's always unique to that particular pattern of text, if you like. It doesn't matter how big the file is. It can be tiny or it can be a million lines of code. It will always generate a number. And it will always generate the same number if the text is the same in the file. So it therefore knows if you make a change to that file, because when it runs through the hash again, it'll be a different number. And that's what it can do, these diffs. It can say, I know these files are different, and then it can do that textual diff where it actually compares line by line and finds out the line that's changed. But at a file level, it can just run the hash and see that there is a difference because the hashes are different values. And that's what's great about this. If you send this file off to somebody on the other side of the world and they're working on something, if they make a change that's the exact same change as you and they run the hash, they'll get the exact same hash number. And when they commit that back to you, Git knows that those hashes are the same. And equally, if they create their own branch, you create your own branch locally, you both make changes, Git knows what files have changed, because when it does those hashes on those changes at the merge request, it can figure out which ones have changed. So it's very clever use of hashes, and it's one of the underpinning things of Git. It's how all these things hang together. So you can do a lot more with Git. I think for now this is enough that you understand that there is more to it. There's a free book online that's called Git Pro, and that talks you through how to do everything step by step. It's really worth downloading and having a read through. But for now, understand that Git's free. You can download it, you can start using it today. It's very easy to get started with, and it makes your code safe and secure. And most things like VS Code, other editors also understand source code control, and they can use Git too. So really great for securing your code. So I promised at the beginning of the stream I would tell you some exciting news that I've got. So two pieces of news that I can share with you. The first one is that we're starting a whole new series. So this was the end of the Learning Python series. The next series is going to be starting from scratch. Everything everybody needs to know to build their own SMARS robot. So from the 3D printing, setting all that up, assembling all the parts together, all the electronics, wiring all that up, loading the code into there, everything you need to get started. So that's a whole new series that I can't wait to get started on from next Sunday. And the other piece of news is that I'm currently broadcasting from my own living room at the moment. This hasn't been great for everybody who lives with me, because obviously I have to have the whole house to myself as I'm broadcasting. So I've purchased a garden office, and this is going to be my live streaming studio. It means I can have all the equipment set up. We can have a nice set design behind with all the SMARS and memorabilia and things like that. So this is going to be really awesome. So over the next 8 weeks, that's going to sort of come together. We've ordered the office. We've got everything ready to go, and all this equipment that I've got will be set up really correctly, really sweet configuration of all the equipment to bring you better content. So cannot wait for that to happen. So that's two pieces of great news. New series on a beginner's SMARS, and the second one is the studio. Let me have a look what else. So this new studio, it's going to be purpose built. So 3D printing will be an area. At the moment I've got my desk, and it's just squished in one side next to my my main area here. So I'm going to have a much bigger area to work on. It also means I can have a camera pointing down. Obviously have specific cameras to switch to for that. And electronics parts and storage. So currently I've got my electronics stored all over the house. There is circuit boards everywhere. My desk is currently cluttered with all things like this, just hanging around, wires everywhere. So it'll be properly set up as like an electronics workstation. So I'll have a permanently set up workbench. There'll be a build area, so like I said, with the camera overhead, so if I'm doing some soldering, doing any kind of making, assembling, we'll be able to do that much easier. Currently I have to sort of figure out how to have a camera pointing on, like using my 3D printer as a platform. That's not really great for it, so it means I have to level the bed every time. What else is there? So the studio camera and the cameras for specific activities such as soldering, drawing diagrams and so on, that's all going to be great. Currently we've just got the one camera here. I sometimes have a SMARS cam over here. Sometimes I bring in my mobile phone as a third camera. We're going to have more cameras. And yeah, the background. So instead of it just being my staircase, my living room here, it's going to be a much more interesting scenery behind me. It's going to be themed to robotics. And the lighting as well is going to be a bit better. So I'm well illuminated here, but everything behind me is quite dark and moody. So it's going to be a much brighter and more interesting place to watch. So yes, cannot wait for that. So I was going to tell you the story as well about you were talking about before about having accidents and things when you was a kid, or your kid was having an accident. So when I was at school, I was talking to my family about this the other day. I was a really picky eater. So I was on school meals and they had this rule that you couldn't leave the table until everybody had finished the meal. Now I was quite a bad, I was a picky eater. So if I didn't like the type of baked beans that they had, for example, I wouldn't eat them. And therefore everybody'd start hating on me, saying, you know, why are you not eating your food? So I figured out that I could hide my food. This sounds really bad, but I would hide my food by sort of palming it off the table. And then the table itself was made up of this aluminium tubing. It kind of went in a... I shall draw you a diagram on here. So the table kind of had tubing like this with the sort of worktop on there. And that was where people sat and ate. So this tubing kind of went down there and then up. And it was hollow tubing. So I figured out you could stuff food down this tubing, and that meant that you didn't have to eat it and that you could get out to play quicker. So I started shoving food down there, and I did this for months. You know, I didn't really want to eat anything. I would just shove it down this tube. And given they must have had about 20 different tables, you're never guaranteed to get on the same table or even be sat in the same place twice. So every time I would be shoving food down this aluminium tubing. Anyway, one time, the girl who sat opposite me, she starts screaming her head off, saying, there's a worm, there's a worm. And what had happened was, I'd finally reached the point where I was pushing in some food into one side of the table, and on the other side, all this rotten food was being pushed out the other end. And she thought there was some kind of worm coming to attack her. And I couldn't bring myself to sort of admit that that was me. So, yes, that was a bit of a traumatic story from childhood anyway. Thought I'd share that with you. It's fine, I was laughing at that one. Horrendous, but yeah. I'm a much better eater now. I enjoy lots of different food. So you had another comment there as well, Spinebone. So you've been saying about GIT. So you're saying you have to set it up. Holidays are over, so I'm going to start more of everything. Fantastic. Yeah, it's good, isn't it? Sometimes you don't have the time to do everything you want to do. So when I started doing these live streams, I had about a month in between contracts, so I had a lot of time to you know, figure out what I was going to do next, and you know, learn how to do this really. So yes, please remember to like where are we? Like, subscribe, and tick the little bell as well. Yes, I made that myself, can you tell? And what I've been doing over the past month in August as well, there's been a secret group on YouTube called Live Stream Every Day in August Leader, and there's been some experts in live streaming who've been teaching us every day different techniques to make our live streaming more engaging and better. So hopefully you can tell by the interaction how I'm sort of engaging with you, making more eye contact rather than just sort of having my head down, using the right equipment like the microphone, the headsets, and so on. That's where I got the streamer hat from as well, from their store. So hopefully that's made these things a little bit more engaging and interesting. That's my boss also saying GIT seems legit. It is properly legit, definitely. Cool. So that's everything that I had for you today. So like I said, please make sure if you're watching this on replay, leave me a comment, say hi. You know, I like people when they interact with me and they sort of drop a hi in the comments. I also look for comments of the week as well. We did have a comment, which was Uday did the previous one, but there was another comment. Let me just see if I can find it on my other monitor before I bring it in, just in case. You know, you can actually get kicked off YouTube if you bring comments in that are, you know, not friendly in some way. Even though you've not made the comment, because you've not got rid of the comment, they sort of put it onto you, really. So I'm just going to check through my comments on my other machine. Just bear with. Let's see, I have to go to YouTube Studio, and I'm currently at 91 subscribers. We just need 9 more to make it to that 100 mark. That'll be my first milestone of 100 subscribers. So if you haven't subscribed yet, shame on you. Hit that subscribe button. Right, let's have a look at the comments and see who we have a comment from recently. I did have a lot of very kind messages as well. You might have seen, originally we were going to have this live stream on Sunday evening, but my dad had a stroke. He had a tear, I think it's called. It's not quite a full-on stroke, it's a mini stroke, but it did mean that there was a bit of a family emergency. He had to make sure that he was okay. He's doing really well now. He's just got a little bit of tingling in his fingertips, but yeah, he's in really good health actually anyway, so it was a bit of a surprise when this happened. But yeah, much love to the father, and he's doing really good, so that's brilliant. I can't find the comment, so make sure you leave me a comment. I want to know what kind of machine that you use, so type in the comments, whether you're watching on the replay or whether you are watching live, what OS you use. Are you a Mac? Are you a Linux? Are you a PC? Are you Windows? What kind of OS are you using? And also tell me what your favorite kind of board is. Do you use Arduinos? Do you use Raspberry Pis? Where are we? That's a clone of an Uno. Do you use a Raspberry Pi? What's your go-to board for developing? Is it a Node MCU? So leave me some comments on that, and I'll look at those later on. So it's fine, but I'm commenting on the last one. Like that you showed all the... Sorry, let me just bring that one up. Commenting on the last one. You did comment on the last one, so you are the comment winner of the week. That's correct. You like that you showed us all the half-finished projects. Yes, my box of unfinished joy over there in the corner. Really liked the idea of making it without a 3D printer. That's right. So I used a shampoo bottle that I'd chopped in half. I'd cleaned it out so there was no product in there. Put some servos in there. Heraldited them in there so they were properly glued in. And I also put some LEDs so that it would flash. And it just shows you don't have to have a fancy 3D printer to build some robots and get started. So yes, you like the idea of that. So you win indeed, Sveinborn. Absolutely, you are the winner. You get 1,000 points. When I have my own merch store, you'll get a T-shirt or something, but I'm not there yet. I need to get the monetization up. So I need to get. I'll tell you how many people I need to get. I need to get 1,000 subscribers before we. So that's why I said the first 100. When we've made it to there, that's 10% of the way there. And I'm seeing a healthy growth in the channel. We're getting a couple of subscribers per day currently, so we're not far off. I think by the next time we do a live stream next week, we may well have hit the first milestone, and if we do, we'll have a little mini celebration. So yes. We'll have to do some SMARS fan t-shirts. I've currently got my Game Over t-shirt on. Big fan of retro gaming, Pac-Man and so on. Great, so I think we're going to leave it there then. And I shall see you very soon for the next one. Just see my other lights have come on. That means I've got a scene set, so when it's dusk, the lighting changes. So that means the sun is setting. So I shall see you anon next Sunday, 7 p.m. British Summer Time. And take care. Ciao for now. Or what I should say is, so get building, get coding, and have a whole load of fun.